Hello, thanks for joining VDI with XtremIO X2 session. My name is Chandamoy Mondol. I am the Director of Storage Solutions. Today I am joined by Tomar Nahumi, who is our Solutions Architect. Together we are going to showcase how XtremIO X2 is a wonderful platform for your VDI deployment based on a lot of hands-on testing on both the leading VDI platforms, VMware Horizon and Citrix Zen Desktop. We are going to share VDI best practices with you and touch upon what's new in XtremIO X iOS 6.1 as it relates to VDI. Now, the entire globe is being affected the rapid pace of digital transformation. IDC estimates by 2020 there will be 7 billion people with 30 billion devices creating more than 44 zettabytes of data. That's massive scale. How does IT keep up? How do you deliver virtual desktops as part of your all-inclusive end-user computing strategy to your end users? Now, VDI is not really new. We have been delivering VDI for the last decade or so. Yet, as we work with IT organizations, we hear about storage challenges and concerns about delivering anywhere, anytime, any device access. The number one problem that we hear is the VDI platform, storage platforms inability to deliver high performance with consistently low latency while reducing the capacity footprint needed to deliver this deployment. The other concern is having the ability to start small and then affordably and non-disruptively grow as your needs increase. With the platform that is intuitive, easy to manage, requires minimal planning. And finally, faster VDI deployments along with easy maintenance is the another ask. Now, XtremIO is in the market for nearly like 4+ years. From day one, we have found that VDI is an important use case for XtremIO because its purpose-built all-flash array architecture inherently aligns very well with VDI storage needs. For example, the array is inherently balanced. It's N-way truly active-active controller architecture that helps us deliver very high performance with consistently low latency irrespective of VDI workload, different types of VDI users, or the state of the VDI desktop in its life cycle. We have industry's unique inline all the time data services, especially the deduplication and compression data services that helps us reduce the capacity footprint irrespective of whether you are doing full clones, linked clones, or instant clones. Couple that with always in-memory metadata, and VM cloning for VDI becomes a snap. And finally, we have solid integrations with both the leading VDI platform software. Now, as I'm mentioning, we have our new XtremIO X2 X-brick, and with this very small footprint of a single X-brick, we can deliver 4,000 virtual desktops, and we have validated this at every stage of desktop lifecycle with both VMware Horizon 7.4 and Citrix Zen Desktop 7.17. Now, how did we validate this? Let's take a look at the virtual desktop lifecycle. We can classify it into 3 distinct stages. First, you need to provision the desktops. Once that is done, they are in production use where users are logging in, working, logging out. And then there is VDI desktop maintenance tasks, such as you need to patch the environment, you need to update the OS, you need to redeploy the pool, so on and so forth. So we are going to take a look in all these three stages, starting with desktop provisioning.
Okay, so when we talk about VDI usage, so the most common platform is Horizon View. And in the next couple of slides, we will see how XtremIO X2 integrates with VMware Horizon in each of every steps that Chandomai mentioned before. So in Horizon, we have three types of clones: full clone, link clone, and instant clone. So when we talk about full clones, a full clone is a complete copy of the master image which is created and personalized with sysprep or a similar solution. This is more often used for persistent desktops and can be greatly improved with VAI Hardware Assistant. When we talk about link clones, so a link clone is a complete copy of the master image which is created as a read-only replica. The delta disks are created for each VM, representing the changes from the replica. This solution often uses for non-persistent desktops. The replica and the link clone creation process is managed by a component called Composer, and the Composer passes off most of the work to the vCenter and the vSphere layer. The next cloning type is instant clones, which is known as VMware Fork projects. In this type of cloning, the master and the snapshots are smashed together into a template. A copy of the template is created as a read-only replica. A parent machine is created on each host and powered on, and then the instant clones are forked from a running parent virtual machine. The template or the replica or the parent and the link clone creation process is managed by a vCenter and doesn't require to use the Composer. But one of the disadvantages of this cloning type is that it can only be used with non-persistent desktops, since when a user logged off from his desktop will be deleted and a new one will be created automatically. So if we look at our current customer base, we can see that almost 60% of our customers are using full clones, while only 40% are divided between link clones and instant clones. So now let's try to understand how a conventional VM cloning with VAI Xcopy is working. So for those who are not familiar with VAI Xcopy, so basically in this SCSI operation, the E6i hosts send Xcopy commands to the storage array in order to offload heavy and intensive operations such as cloning virtual machines, deploying from templates, and so on and so forth. So by this, the E6i host reduces the memory and CPU load as well as the load on the HBA card, but actually it's just moving this heavy operation from the E6i host to the storage array. Now let's see how XtremIO X2 architecture implemented Xcopy in order to provide this lightning fast for hundreds and thousands of desktops simultaneously. So since XtremIO metadata is distributed across all of the memory of each storage controller, so basically when we clone a virtual machine, we're just pointing new metadata pointer to the existing blocks on the SSD drives. And this gives us the ability for instant VM copies and cloning of hundreds and thousands of XtremIO in-memory metadata. And since this is only metadata operation, so no storage capacity, performance, are required. And now let's see a demonstration of these lightning fast full clones.
So now, as we were explaining, the cloning in XtremIO happens in memory at a lightning fast speed, effectively delivering a throughput that's higher than the physical bandwidth available between the ESXi host and the storage array. So here we are going to create a new desktop pool, full clones. As we select the full clones, then we select the next steps. We provide the name to the desktop pool that we are going to create. We are going to select the naming pattern, and we are going to create 4,000 desktops in this cloning test. Once we complete that, we go to the next step. We provide the VM folder, like where it's going to be created. We choose the template, we choose the ESXi host, and finally the 10 data stores that we are going to use for creating these 4,000 desktops. Once we are done with this, we are ready to kick off this cloning process after we pick our customizations. It moves along. So as the next step, we are ready to complete the task. Now let's take a look at the vCenter to see that we are seeing it's getting ready to start the cloning process, and you can see the folder is created, and now the VMs are starting to get cloned. You can see the very fast cloning process that's happening here. Maybe 10 or so seconds has passed, and you see more than 100 VMs are already cloned. Now if I come back to the XMS GUI, you see that right now we are driving nearly or more than 40 gigabytes per second throughput. That's an insane bandwidth, because our 16 gig fiber channel gives you only like 4 gigabyte per second throughput pipe, but because of this in-memory cloning, we are able to drive much faster workload. You see that the storage controller is fully balanced. All the 4 CPUs are evenly balanced. Let's take a look at the block size distribution. You can see which block size is responsible for how much throughput that's getting delivered. Not only for VDI, for your other workloads, this is a pretty useful feature. We can see the overall performance at various points in this cloning process. We can see the IOPS that were needed. We can see the throughput needed. So these reports come in pretty handy as you analyze not only your VDI workload cloning process as we are showing here, but also any other workloads that you might be running on XtremIO. And again, like the takeaway is the high throughput, higher than the physical bandwidth available, that we were able to deliver to the ESXi hosts because of this always in-memory metadata cloning without touching the data plane with SSDs. Now, we have done this cloning experiment between all these different cloning types: full clones, linked clones, instant clones. Remember, full clones are for the persistent desktops. Linked clones and instant clones are primarily for non-persistent desktops, although there are additional techniques that you can apply to create persistent desktops from these methods. But if we take a look here, we could clone 4,000 persistent desktops in less than 2 hours. This is like 110 minutes. That's literally 1.5 seconds to clone a full VM. On the other hand, for linked clones and instant clones, because of the nature of the process, they are faster than full clones. These are non-persistent desktops. Linked clones took 75 minutes. But look at the insane performance we drove for the instant clones as well, because we could create 4,000 instant clones in 22 minutes. That gives you 3 VMs or 3 VDI desktops in literally like 1 second. And as you look at the next row, for the bandwidth consumption, full clones are driving very high throughput, 30 gigabyte per second. The bandwidth usage understandably is much lower in linked clone and instant clones. The IOPS Obviously, full clones need a lot of like high IOPS, whereas the IOPS needs are pretty small, are relatively smaller in comparison with full clones for linked clones and instant clones. Now, as it relates to the data reduction, remember we mentioned we have always on inline all the time deduplication and compression in the data path. Because of the nature of full clones, where you have fully copied VMs across the board, you get a very high data reduction. We have a conservatively 10:1, but in reality, you are going to see more than this. For linked clones, typically we see anywhere between like 3:1 to 3.5:1, and then instant clones give or take like 2.5 to 3:1 data reduction ratios. Here is an interesting chart that we want to showcase. We want to show you how the IOPS versus latency look like for every cloning process. On the extreme left, you see the cloning of full clones. Now, the latency is very low. We are delivering like greater than 200,000 IOPS at 400 microsecond or less latency. When you come to the linked clone, you see that the array was delivering like between 80 to 120K IOPS at give or take like 400 to 600 microsecond latency, which is like amazing. Now, interestingly, you see that the latency curve, it is taking a lot of space, or it has the latency scattered in the instant clone, and you wonder why. So think of it this way. You have 4,000 desktops. They are getting cloned. Whether it's a full clone or linked clone or even an instant clone, after the cloning is done, these are being powered on, customizations are being applied, it is joining the AD domain, sysprep is being applied. All those things need quite a bit of IOPS. And when you see the instant clone, remember, it is delivering 4,000 VDI desktops under 20 minutes with tremendous amount of small random IO coming down to the storage, and even like we can see it is kind of like clustered within like 400 microsecond to 600 microsecond latencies. So that's an amazing performance by the XtremIO X2 array. We want to show you how the IOPS and bandwidth look like side by side for all of these three cloning processes. The first one, you can see it took 110 minutes, very high throughput constantly, very high IOPS throughout. In the middle one, you see the linked clone. For linked clone, the throughput needed was much smaller, and it had a constant IOPS. Now, the interesting part you see in the bottom one, the instant clone. In this instant cloning process, first you actually have to like copy the parent VM into the data stores so that the parent VM can fork the newer VMs. So the first part of this process has a very high throughput. Once that was done, then you see the throughput dropped tremendously, throughput needs, and you see the high IOPS needs that are coming from the powering on, customization, and other processes that are going on as VMs from instant clones are coming live and joining the domains. This gives you an understanding of how the block diagram histogram looks like for delivering different types of IOs. Again, this is useful not only for VDI, but also any type of workload that you might be running on XtremIO. You see, for full clones, it's like 4 kilobyte and higher blocks that were mostly used. But on the linked clone side, you see a high percentage of very small 512 byte blocks that delivered like almost 40 million IOPS, and those very small IOs are coming from the way VMware takes snapshots, does the powering on, applies sysprep, etc.
Okay, so when we talk Horizon desktops in productions, it consists of three main phases: bootstorm, once the administrator apply patches or fixes like Windows updates or antivirus definitions, or when the users log off by the end of the day. The second one is the login storm. So every morning there is hour or 2 hours when all the users log in into their desktops, and this is a very heavy operations from storage perspective, since there are a lot of applications and the operating systems loads, as well as creating the profile or copying the profile from the NAS server. And the third one is steady states, when the users are connected and run their applications. And now let's see how XtremIO X2 copes with the challenges for each and every step that we've mentioned here. So on the screen, we can see a booting process of 4,000 desktops simultaneously. So we can see the very high performance IOPS and bandwidth, and we also can see that this operation took only 10 minutes to complete, which is a very, very impressive. We can also see the controller CPU usage, which is about 70%, but a more interesting thing is the synergy between all the storage controllers under the same XtremIO cluster. So as we mentioned before, XtremIO is a fully active solution, while all the storage controllers participate in serving the read and write IOPS for every LAN and for the whole system. And by that, we can give the users the consistent and predictable performance for their applications and customers. So when we talk about production use, we talk about Login VSI. So for those who are not familiar with Login VSI is the testing tool, the industry standard testing tool for virtualized desktop environments. So these tools load and benchmark the side of resources, and this is a vendor agnostic tool. So it orchestrates multiple virtual users who mimic the real user behavior of actual end users, such as compressing files, sending emails with attachments, browsing websites, watching videos, and so on and so forth. And it's automated for large-scale testing and simulates industry standard workloads. Now, it's very important to mention that for each and every application and session, Login VSI measures the response time and the performance for the applications. So this is the result graph that Login VSI generates for each and every test that takes approximately 1 hour. So here we can see the 4 common Login VSI workloads. The most common one is the knowledge worker, which generates approximately 8.5 IOPS per session. On the right, we can see the test process. So it starts with logging in to all of the desktops using components called Login VSI launchers. And once a user is logged in, he will start generating scripts that mimicking real user scenarios. And then we will start do this over and over until we will reach the amount of desktop that we've set and we wanted to test, which in our case, the 4,000 desktops simultaneously. Okay, so when we talk about our test infrastructure, so we have vCenter 6.5 Update 1, which is connected to a virtual SQL server, and the authentication is done using Active Directory. To creating, maintaining, and provisioning the desktops, we've used Horizon 7.4, and for this Login VSI test, we've used Login VSI 4.1 port 0.32. In addition, we've used the Virtual Storage Integrator, which is a tool that's provided by the Dell EMC. This is a free tool that allows us to integrate with the storage directly from the vSphere web client, and by that, doing a lot of daily tasks directly from the vSphere web client. We will elaborate on this in the next slides. If we talk about the physical connectivity and the physical hardware that was being used for the test, so we can see that we have a cluster that manages 30 ESXi hosts, and these are connected via 16 gigabyte fiber channel to a single XtremIO S brick, which has 18 SSD drives. And now, let's see a live demo of 4,000 concurrent users running knowledge worker workload on Horizon View instant clones. So on the screen, we can see the Login VSI management console. And this console will be used to configure and run our tests. So here we can see the amount of sessions and the workload type. Here we can see the desktop names and the user that will be connected to our desktops. And now we're ready to start a test. So by clicking Start and Next, we're specifying the test name, hit Next. Then we can see the launcher configurations. By clicking Next, we will connect to each and every launcher, and when they are ready, we can start our test. So if we open a console to one of our launchers, we can see that the process is loading, and once finished, it will connect to the desktop randomly and start generating real user workload. So when we go to the vSphere client and open a random console to one of our virtual machines, we can see that a user is already connected and running this operation that I mentioned before, such as sending emails, browsing websites, compressing files, and so on and so forth, while in the background, the Login VSI manager is measuring the performance and the response time for each and every application. If we go to the virtual machine settings, so we can see that we have one VMDK file for the operating system and another one which is app volume of Office 2016. In this point, I will fast forward the video and we'll go to the XMS when we can see the results of the test. So if we go to the Performance tab, we can see the linear graph. So the more users are connected and running, the more IOPS and CPU are being consumed, up to the point where the 4,000 users were running, and from that point, Login VSI started disconnecting the sessions. If we go to the Latency tab, we can see the amazing response time. So we can see that during all the tests, the latency was below 0.4 millisecond, which is really, really a great achievement in comparison to X1 and in general to the other all-flash arrays. If we go to the CPU utilization tab, so again, we can see the synergy between all of the storage controllers, and we can see that they are balanced and almost equal during all the operation, and by the peak, they reached almost 40%. Another interesting view is the blocks tab. So on the screen, we can see the blocks distribution for each and every point in time during the test. So we can see that they are also increasing linearly, but they are almost the same. Now, this is a very, very important graph that shows you for any given time what was the block distribution, and if you made some changes, how it affected the blocks and the performance of your workload. On the screen, we can see the Login VSI results for the 4,000 simultaneous users. And we can see some very interesting terms and points here. So first of all, we can see that the 4,000 sessions ran successfully without any issue, and there were 0 stuck sessions, which means that all sessions were up and running during the test. The next term that I want to focus on is the VSI base. And basically, the VSI base is the best performance that Login VSI measured during the test. The VSI max threshold is the VSI base plus 1,000. And our goal is to not reach the max threshold during all the tests. And the red X indicates that we've reached this login VSI max, and from that point, there will be a performance degradation. Now, if we take a look at the graph, we don't see the VSI max red X, and as a result, we can understand that the performance was really, really great during all of the tests. And we can see that we will be able to run more than 4,000 simultaneous desktops without affecting the performance. Another term that we can see here is the VSI max average, which is a very, very great number for this a large amount of users. You can find more performance comparison on the Login VSI site and compare them to our X2 results. As we saw before, the latency during all the tests was below 0.4 millisecond latency, and this allows you to enjoy a consistent and predictable performance and response time for your end users and applications, no matter what scale, what application, what operating system.
So far, we have discussed the desktop provisioning, desktop production use. So let's close out this section with desktop maintenance. With Horizon, there are 3 types of desktop maintenance operations that are common. If you are doing link clone, there is link clone refresh. What it essentially means is you have your master image that is read-only, but you do not need to touch it, but then the scratch space that was attached for each individual VM that grew in capacity, you discard it and start over. So everything becomes a pristine desktop. This is the link clone refresh process. Link clone recompose is when you have to update the read-only master image. Say, for example, you are applying a patch, you are upgrading your antivirus, or you need to upgrade your applications, etc. So in that process, you essentially recompose the master image and then deploy the link clone pool. Instant clone pool push image is similar to link clone recompose, but it applies to the instant clone process. Now, if we compare the link clone recompose and instant clone push, which are similar operations in terms of what it does, mainly updating the master image and then pushing those so that the link clones or instant clones can be created from there. Now, we took only 90 minutes to recompose this 4,000 desktops, and remember, these processes are very, very storage intensive. As you can see, both of them were driving somewhere between 140,000 to 160,000 IOPS and driving like 1.4 to 2.7 gigabytes per second throughput. But for the storage, like it could deliver in flying colors, and you can see that controller CPU usage were anywhere between like 30 to 40% during these maintenance operations. Here are some of the charts to showcase how the IOPS and throughput are compared between various desktop maintenance operations. The middle one is link clone refresh, where it essentially discards the scratch space, and you can see a reasonably stable graph here, meaning like there is no variations as such. But if you take a look at the link clone recompose at the top and instant clone push image at the bottom, you'll see at the beginning where there was copying of the master image was going on, there was like a high throughput, and then that falls off. On the bottom one, in the instant clone push image process, it's actually like a 2-step process where you first have to get rid of the instant clones, then update the image, and then again copy it like each of the single data stores. So you see at the onset very high throughput usage, and then the throughput falls off. You see the IOPS usage throughout the remaining of the process. The block diagrams for the block size versus IOs, kind of like similar to what we have seen in the cloning process. Instant clone has 4K blocks, 8K blocks, etc., higher block size. But both link clone and instant clones have significantly high IOPS at a very small block size, namely 512 byte block size. Again, this is because of inherently how VMware does its snapshots, how like the booting process, the customizations, etc., create these small blocks. So to summarize, whether you are doing full clones, linked clones, or instant clones, XtremIO X2 can do a very high number of those desktops with a simple single X brick, always with high performance, ultra low latency, and a great inline storage efficiency.
Okay, so with that, let's now go to the most interesting part, the VDI best practices. So first of all, as part of my role, I'm responsible for developing, writing, and publishing these white papers and reference architectures. So these can be downloaded from the links here or from the Dell EMC site, and there you will find full details of the analysis of the virtual desktop lifecycle for full clones, instant clones, and link clones, as well as production use and desktop maintenance that we've mentioned here. Okay, so first of all, the VMware Horizon settings. So if you go to the Horizon web client, web interface, and go to the vSender that is connected to your Horizon connection manager, so you will find the maximum concurrent operations. And the default values for most of these operations, most of these values are 20. And with such a strong array such as XtremIO, we will be able to increase this value by 6 times for almost all of these concurrent operation settings, and by that, shortening the time that it takes to provision this virtual machine, as well as shortening the time that it took for the maintenance operation, and this gives you, the customers, to enjoy the full performance that XtremIO can give you at any given moment, whether it's provisioning the desktops or maintaining them. Concurrent Xcopy clones. So under the vCenter advanced settings, there is a parameter called config.vpxd.resource-manager maximum cost per host. And basically, this is the number of the concurrent Xcopy operations, whether it's storage vMotions or cloning from live virtual machines or templates. So by doubling the value, the default value for this parameter is 8. And by doubling this value, we are able to run more cloning operations concurrently and increase the performance of our X2 brick, and as well shortening the time that it takes to complete this creation of these pools. Next, so there is a tool, free tool from VMware Flinks called VMware OS Optimization Tool. This tool can give you great benefits by optimizing the master image of your VMware Horizon. So I very, very recommend to use this tool. All you need to do is go to the VMware Flinks site, download the tool, install it or your golden or master image, select your operating system. After that, you can click on Analyze, and this will scan the services and the processes that run on the virtual desktop. And after that, by clicking Apply, it will disable them, and by that, will give you much more performance. So from tests that we've done, we found that we will be able to save between 15 and 20% of CPU and memory utilization at the E6i cluster level, as well as reducing the IOPS and bandwidth and the CPU utilization in our X2 array. So basically, this gives you a better performance and response time for your users, as well as the ability to run even more and more desktops simultaneously. The integrated management with VSI plugin for vCenter. So I mentioned this tool before. This is a free tool that is developed by the Dell EMC team, and actually it integrates with the vCenter client and allows day-to-day operations for the VMware administrator and to run them directly from the vCenter web client. So by installing and configuring this tool, you will be able to provision new data stores directly from the vCenter, and by that, new LANs will be created at the XtremIO level, will be mapped to all of your E6i hosts under the cluster that you selected, and then a VMFS data store, wherever it's version 5 or 6, will be created. You can also extend existing data stores, monitor the XtremIO storage in terms of deduplication and compression for each and every data store, as well as physical and logical capacity usage. A very important ability is the schedule space reclamation at the data store level. This will give you the ability to free up occupied space from your data stores and send trim or unmap commands to the storage array, and by that, freeing up the space at the storage array level. Another ability is taking XtremIO snapshots directly from the web client, and this gives you the ability to create the XVC snapshots and protect or back up your virtual machines as well as the management platform. A very, very important ability is the option to apply the XtremIO best practices with one click directly from the vCenter web client. So instead of opening the host configuration guide and go for each and every host and apply the best practices using XMCLI, ES6 CLI commands, all you have to do is select your cluster and with a few clicks, apply the best practices. So before I mentioned the reclamation. So unmap is another VAI primitive that basically allows you to send unmap commands from the E6i host to the storage array in order to free up space at the storage array level. So there are multiple ways to do this. The first one is using ES6 CLI command and specifying the XtremIO best practice volume, XtremIO best practice unit size, which is 20,000. Another and very recommended way to do this is via the VSI plugin, and by that you can create a scheduler which will run daily, weekly, or monthly, will go for each and every XtremIO data store, and will run this unmap at the data store level automatically for you. VMware released vSphere 6.7 2 weeks ago approximately, and in this new version, there is a great feature called reclamation rate. So this gives you the ability to set a specific reclamation rate for each and every desktop. Now, it's also very important if you have multiple storage vendors which are connected to the same vSphere cluster. And by that, you will be able to send automatically in-guest reclamation commands, as well as at the data store level commands directly from the automatically without doing anything. So as soon as a user is deleting files from his virtual desktops, or when you move a virtual machine via storage vmotion or delete one at the data store level, it will be automatically removed from the LAN level. Reclaim space and viewer storage accelerator. So these are advanced parameters for link clones desktops. So we recommend to enable the reclaim space, and actually it will go for each and every desktop and reclaim the space during maintenance operations such as rebalancing and recomposing for link clone desktops. Another recommendation is to not enable the view storage accelerator. So this basically creates additional usage of memory in order to improve the performance for the virtual desktops. Now, with XtremIO, we are more than satisfies the user response time and performance, and therefore we don't need to consume a lot of RAM from the E6A host, since the performance are very, very good for a very large of simultaneous desktops. Okay, so how many of you are using Citrix Zen desktops? Okay, I see that not many, but if you are interested, so I've published 1 month ago a Citrix Zen desktop white paper with XtremIO X2, and all the steps that we've mentioned here, we have them there, and a full analysis of the virtual desktop lifecycle of 4,000 desktops, whether it's PVS, MCS full clones, or link clones, production use, and desktop maintenance. So all of these steps can be found on the link here, or from the can be downloaded from the Dell EMC site. As well, you can find there optimizations for Citrix Zen desktop, such as the CTXO tool and maximum simultaneous action settings for your desktop pools.
For the last section, let's take a look at what's new in XtremIO X2 6.1 as it relates to VDI. The first thing I want to highlight is advanced analytics reporting. It actually helps you with weekly patterns to understand whether your VDI users are using, how they are using the system, whether the patterns are sporadic or consistent over a long period in time. From the heat maps, you can see the IOPS that are being used predominantly at any time during the week. But best of it is you can actually understand the built-in reports tracking the data traffic patterns. So what do I mean by that? So if you take a look here, we actually maintain the average weekly patterns for like 8 or more weeks, and you can see the percentage difference for the current week. So if you see an increased percentage, say for example in this case we are seeing like 500% increased IOPS and throughput in comparison with what you did on every Monday for the past 8 weeks. Now you can drill down and see the IOPS and latency for that specific time and kind of like help you figure out what's going on, whether it was like a one-time system update or something special is happening, etc. The other part of new XtremIO X2 6.1 is giving you the ability to find data reduction ratios on a per volume basis. Previously, it was across the cluster. Now, if you have different data store, you can see for those data stores on a per volume basis what is the capacity you are utilizing. And it helps you in the migration deletion cases, as well as if you are a service provider or you are in a like private cloud type scenario with chargeback facilities, then you can kind of like do that using this DRR per volume feature. We just announced XtremIO native replication. This also is metadata aware, improves upon leverages XtremIO's in-memory snapshot capabilities. It is very easy to use. You can get RPOs of 30 seconds or less with near immediate to 30 seconds of like RTOs. Again, we are seeing vastly reduced WAN usage, up to 75% reduction in WAN bandwidth, as well as 38% capacity savings in various deployments. Another thing to highlight is Dell EMC AppSync. This is a software that enables you application automation and orchestration. You can actually take VM consistent as well as application consistent snapshots using Dell EMC AppSync. Now this is available directly from XtremIO XMS. This is in technical preview now. It will be in the GA soon. So putting it all together, if I were to tell you the top 3 takeaways from this session is no matter what scale you want to do, no matter what type of users you want to do, for your any device, anytime user access, you are going to get uncompromised user experience if you deploy your VDI on XtremIO. For your administrators, it gives you a really simple experience where no tuning is involved. It needs minimal to no planning, and you can easily deliver fully persistent desktops. Combination of these leads to a very low OPEX and CAPEX costs, and you are able to deliver best dollar per desktop in the industry. With the technical innovations, we also have a range of deployment and support services going with XtremIO X2. So you can choose between Pro Deploy, Enterprise Suite support, Pro support, as well as residency services if your scale of deployment needs it. We also have future-proof storage loyalty program at no cost to you, either for the product price or for the maintenance price. This is essentially for your investment protection and peace of mind. For all the details about the program, ranging from satisfaction guarantee, never worry data migrations, hardware investment protection, etc., you can go to dellemc.com/futureproof as noted at the end of the slide. Thank you for joining the session. Hopefully it was very useful to you, learning about the various VDI options as well as like what's new in XtremIO XiOS 6.1. For more details, go to dellemc.com/XtremIO for more general product overview, white papers, as well as all the VDI reference architectures and white papers that we mentioned during the webinar. Thank you.